Are there any questions on the last night's assignment? Any questions on the homework from last night? What we're doing today, guys, is we're finishing up section 4 or 5.1. So the first thing we're looking at is this here: interior angles and exterior angles.
Do you have a pencil? Never give up that. So now nobody.
Now we classify an angle as an interior angle if it's inside the figure. And it's considered an exterior angle if it is outside. The original angles are the interior. The angles that form a linear pair with the interior angles are the exterior. So interior angle and exterior angle will make a straight line. Triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. So if we add all three angles together, we get 180. So if we look at this one here, so this triangle, we have two things we have to do. One, we have to classify it by its angles and find the missing angle. Well, we know that these three angles add up to be. So we can say 47 degrees plus 58 degrees plus x is equal to 180. We can add these two here together. We can add these two together. So 47 and 58 is going to be 105 plus x is equal to, yes. Yes, both will work, which would give you. So the missing angle is 75 degrees. Huh?
So we don't do anything with the x?
Classify it, find the value of x and classify the triangle by its angles. So what can we say? Because if we're classifying it by its angles, it's either going to be acute, right, obtuse, or equiangular. So all three angles. So this is an acute triangle because all the angles are less than 90. Questions on this here? Makes today a little bit nicer. Let's look at this one here. So these three angles add together to be 180. So we're saying x plus 96 plus 21 is equal to 180. So we can add 96 and 21 together and get, and then what? So the measure of angle x is, how would we classify it based off its angles? It would be obtuse.
So what classified by? Okay, never mind.
Do we know the measures of any of the side lengths? More than 90. Because an obtuse angle is between 90 and 180. So as soon as we have one angle that's between 90 and 180, it's obtuse. Because for acute, we need three acute angles. For right, we need one right angle. For obtuse, we need one obtuse angle. And for equiangular, we need three angles that are the same. So looking at this here, 52 is acute, 43 is acute. So if the measure of angle x is acute, it's going to be an acute triangle. So, well, these three add up to be 180, yes? So we could do what? Add these together and subtract it from. So we can say 52 plus 43. And subtract 95 from, which is, so x is 85. And this works out nicely since the third angle is just x. And this would be questions on this here? Any questions on any of this here? So let's look at this one here. Now this one here is a little bit different because they didn't give us two angle measures, they only gave us one, yes? But we do know that the three angles inside this triangle add up to be what? So we can say one of the angles, so 2x plus x minus 6 plus is equal to 180. Now the first thing we can do is combine like terms because on the left side of this equation we do have like terms. 2x plus x is 3x. Negative 6 plus 90 is plus, or 90 minus 6 is 84. Now what do we need to do next? We need to minus 84 from both sides, which will tell us that we have 3x on the left-hand side is equal to, and divide by 3. So why would we need to plug it in? Because what did it ask? Find the measure of each acute angle. X. So one of the acute angles is, so 2 times 32, which is, so one of the acute angles is, the other is x minus 6, so our two acute angles are 64 and 26. Yes. It would be a right triangle. If we were asked to classify it, yes. Questions on this here? We like this here so far? Since it doesn't give us a way to specify them, we don't have to. You're good? Find the value of x and classify the triangle by its angle. So this one we'll need to classify it. So if we're going to classify it, we'll have to plug it back in to see which one they are. So if it just says classify, because it'll classify the triangle by its angles and sides, or one or the other. If it says both, we need both. Here it just says angles, so we'll just need angles. Now we know that these three angles add together to be, so we can say 3x minus 17 plus x plus 40 plus 2x minus 5 is equal to 180. Combine like terms. So 3x plus x is 4x plus 2x is indeed 6x. Now we have negative 17 plus 40 minus 5. Well, we can do that in a calculator. Negative 17 plus 40 minus 5 is plus 18. what would we do next? Minus 18 from both sides. 1. Yes. Is 27? This 2 would be 12, 42. So the value of x is 27, yes? So we have to plug it back into each one to classify it based off its angles. So one of these that we have is 3x minus 17. So we'd have 3 times 27 minus 17. And again, at this point, we could type this straight into a calculator. We don't have to do this by hand. And we get 64. Now the next one we can do is 2 times 27 minus 5. 2 times x minus 5. And again, we could type this into the calculator. And I believe it should be 49. So 27 plus 40 is 67. So how can we classify this triangle based off its angles? It's an acute triangle. Questions on these here? Now the corollary to the triangle sum theorem. So a corollary comes from the theorem itself, something that kind of expounds off of it, something that's quite interesting, is that the acute angles of a right triangle are complementary. They add up to be 90. Now, I can show this here pretty easily, because here we have a triangle, yes? One of the angles we have is the measure of angle A. And we also have the measure of angle B, yes? And since it's a right triangle, the third angle is 90, yes? Sum of any three angles in a triangle is 180, yes? If I take 90 from both sides, this becomes 0, just leaving me with the measure of angle A plus the measure of angle B. What's 180 minus 90? So if it's a right triangle, the other two angles have to add together to be 90. We'll still get the same answer if we add all three angles together with the 90. Yeah. Or this is just another way to kind of see that it does work. Yeah. Well, it does add together to be 90. We could still add all three angles together, set it equal to 180 and solve. We'd still get the same answer. This is just a little bit faster. Well, let's look at a problem here. So we have this here. So I'm going to split my screen in half. You only have to write this once. You don't have to do it twice. So if we look at this here, according to that last property, I can say 2x minus 2 plus x plus 5 and set it equal to 90 because it does have a right angle, yes? The acute angles, the sum of the acute angles of a right triangle are complementary, so they add together to be 90. So at this point here, we can combine like terms. 2x plus x is 3x. Negative 2 plus 5 is plus 3 is equal to 90. Minus 3 from both sides, that tells us that 3x is equal to 87. Because we need to classify it by its angles, yes? What's one of the angles that we knew from the beginning? So what is it? So this is a right triangle. Now, part of the reason we knew it's a right triangle, because we can define it as a right triangle if it has how many right angles? Do we already know it has one? So it's a right triangle. We can. They won't. The only way we can have more than one right angle is if it's not Euclidean, it's not pretty much the form we had. It has to be spherical for us to get more than one right angle. So this is going to be 34, 40, and this should be 56 if we plugged it back in. Now, I split this page in two to show you also if we did this as set it equal to 180 and added all three together, we'll still get to the same answer. Because here 2x plus x is still 3x. Negative 2 plus 5 is plus 3 plus 9 is going to be plus 93. Now at this point here, I could subtract 93 from both sides, which will give me 3x by itself is equal to same exact spot, divide by 3, and x is 29. We'll get the same thing. One's a little bit faster than the other. Questions on this here? Let's look at the next theorem, the exterior angle theorem. The sum of the exterior angle is equal to the sum of the opposite two interior angles. The exterior angle, so the measure of angle 1 here, is equal to the sum of the opposite two interior angles. Now this one here is very interesting, especially how this works. And I will go through and kind of show you how this is true. If we use what we've learned so far, inside of the triangle, so the measure of angle A plus the measure of angle B plus the measure of angle C is equal to what? 180. Sum of the interior angles of any triangle is 180. Now over here we have 2. I'm going to call this angle 2. So here we're really talking about measure of angle C is really the measure of angle 2, yes? Because it's the inside. Now, that straight line, we can say that the measure of angle 1 plus the measure of angle 2 is 180. Well, these two equations here are both 180, yes? According to the transitive property of equality, we can set these two equal to each other because they both equal the same thing, yes? So what I can say is that the measure of angle A plus the measure of angle B plus the measure of angle 2 inside the angle is equal to the measure of angle 1 plus the measure of angle 2. I replace measure of angle C with that 2 so that we know we're talking about the inside of the angle, not the outside. And it'll get there. Now, what do these both have in common? The measure of angle 2, yes? It's just a number. So if I subtracted, those two will cancel, telling me that the measure of angle 1 is equal to what? Measure of angle B plus the measure of angle A. This is the theorem. That is the theorem. And I went through that to show you all that this does work every time. In the general sense, this is true, that the sum of the opposite two interior angles is equal to the exterior angle. So the sum of these two angles is going to equal the exterior angle every single time. Questions on this here? So let's look at an example of this. So here, x is our exterior angle. X is the exterior angle. What are the opposite two interior angles? So here, x is equal to 21 plus. Solve. Mhm. Yep. 1 and 4 is 5, 2 and 3 is 5, so 55. Mm-hmm. Yeah. So here, let's look at the next one. So what's our exterior angle? So 122 is equal to the sum of the opposite two interior angles. So here 122 is equal to 90 plus x or x plus 90. Either one works. Either one works because addition, x plus 90 and 90 plus x are the exact same thing. Yes? So x is equal to, questions on this here? Any questions on anything we've done so far? We ready for the next one? So what's our exterior angle for this here? So our exterior angle is equal to the sum of the opposite two interior angles. So that would be plus. So combine like terms, well that's 3 and 51 is 54. At this point here we would subtract 54 from both sides, telling us that 2x is equal to that's it. Questions on this here? We good with this here? You good? Okay, I'm just making sure. So let's look at this here. What's the exterior angle? The exterior angle is equal to what? The sum of the opposite two interior angles. So that would be 2x plus 103 minus x. The exterior angle is equal to the sum of the opposite two interior angles. So we can combine like terms over here, which is 2x and negative x. 2x minus x is 1x. What would we do next? You can, I like going the other direction. I would minus 1x. That's just me. There's nothing wrong with subtracting 103 at this point, but I like keeping the variables positive if at all possible. So 6x minus x is 5x minus 7 is equal to 103. So we can add 7, which will tell us that 5x is equal to 110, because we're trying to get the variables on one side and the numbers on the other. Well, let's see. Solve for, it just asks for x, yeah. If it asks for the values of the angles, then we can find it. Yep. Any questions on this here? So looking at this one here, I think this is the last one or one of them. So what does this one ask for?
The measure is total.
Find the measure of angle 1.
So we can find x and minus it.
Yes. So,
Have to go like that?
so we need to find x.
Which we don't even have to plug it into all of it. We just have to plug
Yes. Or we could plug it into 3x. Because the sum of the interior angles of any triangle is what? 180. These two angles here make a straight line, so they're a linear pair, which means they add together to be 180. So we can go either direction. Now we know that 5x minus 10, the exterior angle, is equal to the sum of the opposite two interior angles. So 3x plus 40. What can we do next? 5x minus 3x is? Minus 10 is equal to? Add 10 to both sides, which tells us 2x is equal to? So x is equal to? So we could say 5 times 25 minus 10. Well, likely 5 times 25 is kind of nice because we can relate it to quarters. If you have 5 quarters, how much do you have? $1.25. So here it'd just be 125 minus 10 is? And at this point here, we can subtract 115 from? Right. Because we could have plugged it into 3x. 3 times 25 is 75. Now, 75 plus 40 is 65. Now we said the exterior angle is equal to the sum of the opposite two interior angles, yes? So when we add the two interior angles together, we got 115, yes? What was the exterior angle? They have to be the same thing. Questions on this here? And this here is why I think math is really cool, is that we have properties that do work like this every single time. And that's what makes it kind of cool. Now, that is it for today. So here's your assignment that you go on to work on it for the rest of the